Thermocouples. The thermocouple is based on the Seebeck effect, a phenomenon whereby a voltage that is proportional to temperature can be produced from a circuit consisting of two dissimilar metal wires. We can think of the junctions at each end of the dissimilar metal wires as producing a voltage, so the net voltage, Vnet, is actually the difference between the junction voltages. One junction is on the probe and is called the hot junction. The other junction is kept at some known reference temperature and is called the cold junction, or reference junction. Thermocouple construction. Arc-welded junction. Some are earthed at tip for improved response time. Conductors insulated by magnesium oxide powder. Normally element is in a thermowel. Commonly element is 1/4 outside diameter. Sheath material, normally stainless steel but can be special material such as Inconel, Incolloy, Hastelloy etc. Duplex thermocouples have two elements inside one sheath. Thermocouple tip types. Ungrounded for use in corrosive and pressurized apps. Slow response time. Offers electrical isolation. Grounded for use in corrosive and pressurized apps. Quicker response time than ungrounded due to improved heat transfer. Exposed for use in dry, non-corrosive, non-pressurized apps. Quickest response time of all three. Thermocouples types. Type K, chromolumal, is the most common general-purpose thermocouple with a sensitivity of approximately 41 microvolts per degree Celsius, chromal positive relative to alumal. It is inexpensive, and a wide variety of probes are available in its -270 degrees Celsius to +1373 degrees Celsius range. Type E, chromal constant and has a high output, 68 microvolts per degree Celsius, which makes it well suited to cryogenic use. Additionally, it is non-magnetic. Type J, iron constant N, has a more restricted range than Type K, -210 to +1200 degrees Celsius, but higher sensitivity of about 55 microvolts per degree Celsius. The Curie point of the iron, 770 degrees Celsius, causes an abrupt change in the characteristic. Type N, nicrosyl nickel, nickel chromium silicon/nickel silicon, thermocouples are suitable for use at high temperatures, exceeding 1200 degrees Celsius, due to their stability and ability to resist high-temperature oxidation. Sensitivity is about 39 microvolts per degree Celsius at 900 degrees Celsius, slightly lower than Type K. Type B thermocouples use a platinum-rhodium alloy for each conductor. One conductor contains 30% rhodium while the other conductor contains 6% rhodium. These thermocouples are suited for use at up to 1800 degrees Celsius. Type B thermocouples produce the same output at 0 degrees Celsius and 42 degrees Celsius, limiting their use below about 50 degrees Celsius. Type R thermocouples use a platinum-rhodium alloy containing 13% rhodium for one conductor and pure platinum for the other conductor. Type R thermocouples are used up to 1600 degrees Celsius. Type S thermocouples are constructed using one wire of 90% platinum and 10% rhodium, the positive or plus wire, and a second wire of 100% platinum, the negative or minus wire. Like Type R, Type S thermocouples are used up to 1600 degrees Celsius. In particular, Type S is used as the standard of calibration for the melting point of gold, 1064.43 degrees Celsius. Type T, copper constant N, thermocouples are suited for measurements in the -270 to 400 degrees Celsius range. Often used as a differential measurement since only copper wire touches the probes. Since both conductors are non-magnetic, there is no Curie point and thus no abrupt change in characteristics. Type T thermocouples have a sensitivity of about 43 microvolts per degree Celsius. Type M thermocouples use a nickel alloy for each wire. The positive wire contains 18% molybdenum while the negative wire contains 0.8% cobalt. These thermocouples are used in vacuum furnaces for the same reasons as with Type C. Upper temperature is limited to 1400 degrees Celsius. It is less commonly used than other types. Voltage to temperature conversion. T equals A0 plus A1V plus A2V squared up to 1V. Thermocouple color coding. The table shows International Electrotechnical Commission, IEC, color code, British Standards, BS, color code, and American National Standards Institute, ANSI, color code for continuous temperature range in degrees Celsius. To watch similar useful videos, kindly like the video and subscribe to this channel.